Hey, good afternoon, everyone. Welcome to the NASA Alumni League First Thursday virtual program. It's March 4th, 2021, and I'm Stokes McMillan. Today we have a presentation by Steve Labbe of Intuitive Machines. So let me tell you a little bit about Steve. Steve is the Director of Engineering at Intuitive Machines, where he serves as the Chief Engineer for their Nova-C Lunar Lander Development Program. Steve brings along more than 35 years of service and experience with NASA, focused on the development of NASA human space flight systems. Among his most recent duties were Chief Engineer for the Constellation Program. He was 8 years as the chief of the division chief of the Aerosciences and Flight Mechanics Division. And lastly, he served as the chief engineer on NASA's Gateway program. Steve retired from NASA in 2019 and joined Intuitive Machines. Long ago, he received his Bachelor's of Science degree in Aerospace Engineering from the University of Cincinnati in 1984. He's a young guy.
Yeah.
So Steve, let me hand it over to you.
All right. Well, thank you, Stokes, for the introduction. Welcome everyone. And it's a pleasure to be here and get a chance to talk about what I'm doing with my retirement life. So yeah, I did retire a few years ago, but I wasn't quite ready to leave the space business, and Mr. Ultimus enticed me to come join him over at Intuitive Machines, and I wanted to talk to you today about that and about how we're going about getting back to the moon. So let me share this. I assume you guys can see that. Okay, does everyone can see that and still hear me?
Yeah, looks good.
All right, great. Okay, so it's going to be a lunar program overview for everyone. I don't know, I figured I'd give you a little background on Intuitive Machines. It was founded in 2013 by Cam Ghaffarian and Steve and Tim Crane. Early on, they were a think tank. The notion was they would take the human space flight methods and experience and know-how and put those into other challenging fields such as energy and medicine and transportation. And they did a lot of things, including oil and gas, medical, and aviation. Even developing a drone that could fly very far and do various surveying. But about 2 years ago, they started moving back into the space realm more in full vigor, and so transitioned that quickly to today, and we're pretty much fully focused on providing space program and end-to-end lunar missions, space communication, engineering services, and even space nuclear. And we're providing those solutions. We've got a team. We've actually been on a hiring spree since we won our second CLPS award, and I'll talk about that. We've added about 30 folks in the last 2 to 3 months. Probably actually up all the way to about 120 employees at our company.
Awesome. Bill, Jim is next.
Hey, somebody's got a hot mic. We're getting a telephone ringing.
Hey, Bill, this is good. What you got?
And it's a pretty good mix of employees. We have a management team that
Okay.
Hey, wait, Steve, hang on. I muted you somehow.
Okay, I think
Oh,
I'm
okay,
unmuted
you're
now,
okay now.
or I think I'm unmuted.
Yeah, you're okay. Sorry.
Okay. Yeah, we have a pretty good team of senior managers with a lot of NASA experience and some journeyman engineers who are highly educated and skilled, all the way down to fresh outs, and of course technicians, because we have to build our spacecraft. So that's Intuitive Machines in a nutshell. All right, why is that not advancing? Okay, so how did we get back to this focus priority on the moon? Well, that was through CLPS. CLPS is NASA's commercial lunar payload services. And so I thought I'd spend a little bit of time talking about CLPS for those who might not be familiar with it. As you can see there, I have some notes. There's been 138 and 77 successful missions to the moon. That includes orbiters, landers, flybys. The last US mission was in 2013. And since then, only China, Israel, and India have attempted landings. Unfortunately for Israel and India, their 2 attempts failed, although China recently pulled it off again and complete with a sample return mission. But obviously, NASA is focused on returning the humans to the moon, and with the CLPS program, they seeded this with payloads and robotic type of scientific missions. There's 14 companies total that can bid on CLPS contract proposals, and the total value of the contract's 2.6 billion actually over 10 years. And they intend to put out about 2 task orders per year, but you'll see it's been kind of uneven. The key here, though, is that the commercial companies build and provide a complete end-to-end service from the Earth to the moon, and that NASA will just buy this service. They're not designing it, they're not developing it, they're not operating it, they're not testing it. They are providing payloads in the form of scientific packages or demonstrations, and resources in the form of money, but not doing any of the engineering or operations. CLPS started with some awards in November 2018. There was 9 companies, including Intuitive Machines, and then 5 more were added in 2019. These awards basically give you permission and allow you to bid on any RFPs that the CLPS program puts on the street. So what has happened to date with CLPS? Like I said, they plan to put out 2 task orders per year. The first one of those was released in March of 2019. It's a very quick turnaround for NASA procurement. So you get the RFP hits the street, your proposal is due in 30 days, and they pretty much award within 30 days of receiving the proposal. So it's fairly rapid paced. The very first task order when there was 3 awards, 1 to Intuitive Machines here in Texas, and we're slated to fly at the end of this year to the moon. Astrobotic up in Pennsylvania and Pittsburgh is another award winner for the first one, and they're also slated to fly later this year, early next year. Orbit Beyond was given a award, but they gave it up. They really didn't do a good job of securing their partnerships with all the different companies that they're partnering with, and so it kind of fell apart on them. But they still can bid on future opportunities. Last year was a blitz of task order releases in January, March, and September. 19C, 20A, Prime 1, and 19D. those words, those letters don't mean much probably to anyone, but 19C was a suite of about 80 kilograms of payloads. TO2 was about 40 kilograms of NASA payloads. 20A was actually the Viper rover that NASA intends to fly to the moon. Prime 1 is the drill that is actually going to fly on the Viper rover and serves as a initial foray, so that that mission will have a single drill site as opposed to with the rover you'll have multiple. And then 19D had about 10 payloads, and I think it was like 120 kilograms of payloads. The ones that are kind of shaded in gold are going to the South Pole. The other two are going to the mid-latitudes. So about $650 million or more so far has been awarded, and Intuitive Machines winning the first award under Task Order 2, and then the Prime 1 award. And we also have this thing called the Hopper. I'll talk about that. We feel like we're a huge part of the renewed lunar focus. Any questions on CLPS? Or you just want to wait? We can wait to the end and have discussions. So how did we respond to this? We had that call and that renewed focus on the moon. We had to say, okay, what do we need to be able to pull off a mission to the moon? And that's our LPDS, our Lunar Payload and Data Services program. You need to do the engineering and the DD&T and develop a lander. You need to have some partners. We have a pretty extensive supply chain out in across the country and actually across the world. We needed a telemetry tracking and communication network, and what we refer to as our LTN, and we've established that. We needed to purchase launch services. We're going with SpaceX and the Falcon 9 for that. And we had to build our own mission control. So this is a picture of our mission control on the 6th floor of what everyone would know as the Boeing building over there on Bay Area Boulevard. And this is where we'll execute the mission later this year. So a little bit more about each of those. When you say the engineering, DD&T and what it takes. So as I said, to get to a service to the lunar surface that NASA can purchase, we got to do the development, we got to do the payload integration, we got to fly the mission to the moon and deliver it to the lunar surface, we got to conduct surface payloads, we got to do our command and control and communication. And what we're really getting paid for is returning data to Earth, right? Our lander will land. The lunar day is nice and survivable for about 14 days, and then it'll be night. And more than likely, if not certainly, our lander will not survive to reawaken when the sun comes back around. I have some pictures here of the development of our propulsion system. We're 3D printing our injector and other components, igniter and the combustion chamber for our rocket engine. We have developed a pretty novel, quick way to do rocket engine testing over at the Houston Spaceport on the back of a truck. I'll show you a little bit more about that. And we're flying all composite propellant tanks. It's a LOX methane system. And these are what are referred to as type 5 composite tanks, where they're linerless. There's no metallic liner internal. And we've been testing them both cryogenically, filled with nitrogen, and done vibe testing and burst testing, and our flight tanks are actually due to be delivered next month. We're also flying an experiment for NASA called radio frequency mass gauging. So in order to determine how much mass we have remaining in the tank of propellant, an RF signal inside the tank is returned, and that's as the spectrum changes with the fill level, we can get accurate gauging. We're flying that as an experiment. It's our secondary method of measuring the mass, but it's been demonstrated on the ground, and we think there's every reason it should work in orbit. A little bit more about our supply chain. As you can see, we're quite distributed across the United States. We have small companies and vendors throughout the country, some large, some larger than others. Some are just machine shops that help us do the post-processing on our 3D printed materials. There's universities involved, and across the world, though, we actually have some vendors over in Europe. Thales is providing some radios for us, and a couple others. One of the things CLPS contract requires is that you be at least 50% domestically sourced, and we're actually over 90%. And then we have our LPDS tracking network locations across the globe so that we can communicate on the way to Earth or the way to the moon back to Earth. And this includes sites that such as the Parkes antenna down in Australia, and Moorhead State University in Kentucky. And then there's a consortium called KSAT that has a series of antennas that are much smaller and not so great for lunar communication, but can serve the purpose when we're near the Earth. So we're flying in November of 2021. This gives you a little bit of a snapshot of what that mission will look like. We launch on a Falcon 9 into a geotransfer orbit. We go once around the Earth and then conduct our translunar injection burn. And then we take about 3 to 8 days. It depends on what day of the month and what month we fly in. We have multiple opportunities. We rendezvous with the moon and inject ourselves into a low lunar orbit. And we stay in that orbit for about 24 hours or a dozen orbits to use our terrain relative nav and test that system that's flying for the very first time, and to hone in on the fact that and demonstrate that it's going to be safe to commit to landing. When we do come in for landing, we're going to land right at the terminator as the sun has just risen on our landing site within the day, and then we'll have a 12 to 14 day mission. Our landing event is all automated using terrain relative nav and hazard relative navigation for precision landing and hazard avoidance. And this is a somewhat close up of our current landing site that we are targeting. It's relatively safe as it goes with landing on the moon for this first mission. We did win what we call our missions IM1, IM2, IM3. That's our designation. We believe we have to fly on the order of annually to be able to sustain the company and have good market growth. We have a manifest on each of these missions that include the NASA provided payloads that we're on contract with NASA to do. And then we have capacity to go out and fly commercial payloads as well from universities or other companies that are interested in doing it. It's surprising how many entities want to fly to the moon to do a wide range of things, from science to imagery to novelty. And so we have a pretty busy phone in interested parties trying to get scheduled on our flights. The second mission will fly the Prime 1 drill. M-SOLO is a mass spectrometer that will look at what the drill brings up and try to identify volatiles. This is going to the South Pole. We also won these tipping point awards, Hopper. I'll show you that on the next slide. And then Nokia wants to demonstrate a wireless communication technology. We still have available capacity on this mission, not only to the surface, but also additional capacity to take to TLI. And then we have our third mission. We're already lining up commercial customers for that. We intend that to be fully commercial. We don't necessarily have a NASA as a baseline customer or an anchor tenant. And we have plans to expand our vehicle. Nova-C can take about 100 kilograms to the surface. Nova-D would be 500, and Nova-M would be a metric ton. We fly on the SpaceX Falcon 9. We only take up a portion of the shroud, and we have purchased the whole rocket for the flight to TLI, and so we can take smaller payloads and not take them to the surface, but drop them off on our way to the moon, or for them to do either journeys to the moon or stay in a very highly elliptic orbit around the Earth. And we have mass to accommodate that. And so this kind of shows you the first mission, we're doing the GTO transfer orbit. The second mission, we're getting a TLI throw from SpaceX, and we'll be directly on our way to the moon. And so we have a little bit of additional capacity and performance that we can use for payloads. So from an end-to-end lunar missions, we have the Nova-C. Well, first flight is this year, and then the second flight would be the end of 2022. Nova-D, we proposed this for the Viper rover. The Viper rover weighs, I think, on the order of 350 to 400 kilograms. We did not win that. Astrobotic won that award, but we are still in the development of this capability for future uses. And then Nova-M would be what we would propose as part of any HLS type of activity for cargo to the lunar surface in support of the human missions. One of the things that's very important about the moon is of course, getting into these extreme areas and having the mobility to do that, like permanently shadowed regions is one. And so we proposed this hopper, which is essentially we call it micronova, is our very small version of our lander, and it uses some of our navigation systems. And what this will be able to do is fly. This is a demonstration mission that we got from NASA as a tipping point to fly about 1 to 2 kilometers away from our lander, go down into a permanently shadowed region, take some measurements, hop back out, communicate back to our Nova-C lander for telemetry back to Earth, the scientific data. And we have proposed larger versions of that can fly and have more significant payload. And then, of course, I mentioned previously the control room and the control personnel, the operations, and our lunar tracking network. And we have bigger plans than that. We see Space Nuclear, and CAM has another company called X Energy that is pursuing different forms of extended energy, so that we can. So the next thing would be to survive the night on the moon. So you have communications, you have survive the night, and you have flying the payloads to the surface, as all areas that we are looking to expand on in the future. So that's kind of the overview of intuitive machines and the lander. So I thought, though, for this forum, I want to do kind of like, maybe this will spark some discussion. We're a small company, new space, but we still need rigor and quality of traditional big aerospace. CLPS, by definition, says that they are willing to take more risk because it's uncrewed missions. And even, I think this has been somewhat chastised, but they use the term shots on goal, where they award lots of these contracts, they don't expect 100% success, and yet by flying multiple vendors, eventually we'll have a viable service. That's all well and good from a NASA perspective. From a company perspective, we can't afford to fail. So we need to determine what's important, use the good stuff we're aware of, and then drive schedule, because we are on a fairly rapid pace. All these CLPS awards come with a fly no later than date. So failure modes and effects analysis. How did we go about taking what we've learned from NASA experience, manage any redundancy for our robotic mission, apply this across not just the lander, but the whole lunar program, making sure that our tracking and communication network is robust, making sure we have backup power in our mission control, and then looking at when and where to fly redundant systems, since mass is such a critical measure in flying any mission to the moon. And so we've taken that, we've exercised that, come up with where we have concerns, where we would have automatic onboard responses, where our ops team would intervene, and how to train for that, and how to divvy that up. Use good stuff. We have leaned on the AIAA standards for mass management. We use the same terminology that is depicted there, and then look at historic and standard rules of the road for how to manage mass growth allowance and mass growth throughout the program, from preliminary design to critical design to what you end up ultimately fielding. There's some pretty good studies out there that look at hosts of spacecraft. Unfortunately, not too many landers in that data set, but hosts of spacecraft, and what was seen as the mass growth from their designs to actual fielding. And we've taken that data and applied that across our various systems. And then driving the schedule. We've really tried hard to drive the schedule with what we call arbitrary and inflexible milestones, doing early integration and risk management. So drive the schedule. We have what we call program technical reviews. This particular one was our PDR for our Nova-C Lander. What we found was some systems were very well potted and mature, and other systems were conceptual. So we used this as a forcing function, had a midpoint check at our PTR3 and another integration checkpoint at 4. And by May of last year, we had our CDR for our vehicle, and all of that happened in about 8 months. MTS, I mentioned we have our mobile test stand, our ability to go do rocket testing out at the Houston Spaceport. What this was a truck. The team bought a flatbed truck, and this is the team about spring of 2019. And we needed to outfit this with propulsion, actuation, flight computers, our software, our core flight system software. What are the procedures? How are we going to control it? Do it safely, build it with appropriate risk tolerance. And we have burned through some combustion chambers and had some component engine failures, but we have not had any safety incidents. And by doing this early integration, we had our prop team, our GNC team, our avionics team, our assembly team, all working together. So here's the team 3 months later, after a cold flow test on the facility. This is a more recent picture where we are doing cryogenic engine firings, and these gentlemen are out there looking for any leaks in the LOX or methane. Our command trailer is parked about 300 feet away during our testing to maintain a safe distance, and this is where we communicate with and do all the testing. We've had some extensive engine firings that we've been able to do. This is we're parked out here on the abandoned runway that is on the south side of Ellington Field that is now part of the Houston Spaceport. We've done 44 hot fires. We've qualified our igniter, and we did some testing also up at Marshall, where with our 3,500 pound engine, we set the record for the engine burn time on that test stand. And then our 900 pound engine, which we'll use to fly to the moon, we've undergone hundreds of tests on that. I mentioned risk avoidance versus risk management. We try to manage our risk. We use a very similar process to what many of us were familiar with from our NASA experience, standard likelihood and consequences. And we do a monthly review of our risks and take action to make sure that we're managing those, both the technical risks and the programmatic risks and the schedule and cost risks. So do what's important, use the good stuff, and drive the schedule is one of the monikers of our culture to try to be successful. We're at a pretty unique time here in the aerospace industry. It's not just at IM, but all around us, we can see that there's a rich legacy that can be used and mined and with new concepts, new perspectives, new technologies, and I think it could be some glorious days for space exploration and commerce ahead. There's kind of an interesting article here that talks about the space economy and commercialization and how to leverage that. So here's a map lunar soft landings, including the Apollo landings and the the Soviet Union, and of course the Chinese. And then here are our 2 potted missions. I am one going to a Mare in the mid-latitude at the end of this year, and then I am 2 landing on the South Pole a year later. So that was my presentation. I have some other stuff I can share with you, but I think maybe I would rather open it up and see if there's questions regarding this material.
Hey, Steve, it's Fred O'Led. Can you hear me okay?
Hey, Fred. Yep.
Hey, I haven't talked to you in a long time.
Yeah, nice to hear you.
Yeah, good to hear you. How are you guys advertising the excess capacity you have on some of these missions? Is that word of mouth, or are you reaching out to other people?
It's mostly word of mouth, but we go to conferences, although obviously the last year has kind of put the kibosh on that and get the word out. Any lunar conferences, we try to make a presence there and make a presentation and let people know, and then it just kind of filters out to the community. And then we've just hired a couple of folks whose focus is going to be truly on our business development. We've been kind of doing that by committee, and these 2 new individuals are almost entirely dedicated to that.
Okay, and could I reach out to you initially with to introduce you to the right points of contact to have further discussions?
Absolutely.
Okay, thanks.
You have my contact information, I imagine. So if not,
I can find it.
okay. Yeah, I'm on LinkedIn.
All right, I'll reach out that way.
Okay, very good.
So Steve, where are your primary hardware builders located?
So Applied Composites is in Southern California. Our structure is an all composite structure, carbon panel with a honeycomb core. And of course, the tanks I mentioned are composite. So they are building our structure and our tank. We are building our propulsion system almost entirely in-house, using our 3D printing and Proto Labs, which is a local outfit, to build some other parts. We're also manufacturing all the struts for our landing gear and the struts that hold our tank. We're assembling those, I should say. We're printing the fittings on the end, and then the tubes are made also by Applied Composites. Avionics is pretty distributed. We're getting parts from all over the country, and even a couple from Europe. But we are also building quite a bit internally in-house, and we have about 20 different boxes on the vehicle, from flight computer to PCDU to other controllers, common track and power, and you name it. So things like batteries and flight computers we're purchasing, but the other control boxes, anything that's going to control the propulsion system, the main engine controller, the valve controllers, we're building in-house. So there's a lot of make-buy decisions across the board.
Oh, sorry if I missed this earlier, but are you doing anything on in situ resource utilization?
Not on our first mission. On our second mission, we're doing 2 things that I would say feed it. We're not actually doing any kind of demonstration, but the drill is looking for volatiles, and the Prime 1 NASA payload drill will drill down, I think it's on the order of 33 feet. And as it brings the core back up, there's a mass spectrometer that will analyze for any volatiles that might be there. And then our hopper is going into the permanently shadowed regions to identify. So we're helping, I would say our step here is helping identify with some more certain information, the presence of water and other volatiles that might be available for in situ resource utilization.
No specific plans for trying to demonstrate and utilize ISRU products yet then?
Not yet.
Okay.
Ultimately, the reason we went with LOX methane is forward looking, of course, to Mars with that in mind, but that's quite a ways down the road.
This is Bill Davidson. Have you used any kind of a red team of outside experienced people to come in and take a look at what you're doing?
We have not done it as a team fashion, but subsystem by subsystem. We've had folks reach back and do independent peer reviews, but not as an overall design. We have not quite done a red team. That's actually not a bad idea to tap into some experience, because we can certainly get our blinders on with our pressing schedule, and an overall look at that would probably be worthwhile.
Hi, Steve. George Abbey here. I just wanted to ask, when it comes to the hoppers that you were proposing that are in your schedule, how far do they go? And then what are they looking for? Are they looking for water, other materials, drilling, or for that matter, does it carry a rover as well once it's stopped hopping?
Yeah. Can't really tell much from these pictures, right? But so the first one is NASA has these things called tipping point that they provide awards for, which is like taking a technology or a capability and demonstrating it to show that it can get beyond from concept to an actual capability. So our first hopper is small and holds about a 1 kilogram payload from Arizona State University, and they're looking to measure for water in a permanently shadowed region. The range on this first mission will probably be up to 1 kilometer, and then down into a crater, and then back up, and then back toward the lander, just as a demonstration. When we get to the larger hopper, we're thinking tens of kilometers and multiple hops to multiple locations, and a larger payload. And we're focused more on the hopper and not so much on the payload itself that goes along with that. That's from our customers and the science community.
Thank you.
Yep.
So Steve, this is a lander and it doesn't have an ascent stage, right?
Correct. No ascent stage. We're just landing. And that's why I said after the sun sets on us, when the sun comes back up, our solar arrays will be there to collect and turn sunlight into power. But doubtful our frozen batteries will respond, or many of the other things. But yes, just a lander.
Any thoughts on sample return yet?
There are thoughts about that. There's obviously discussion in the community about sample return, and it's something that is on the table for us to consider. Those are quite complex missions.
Yeah.
When you land, you have to collect the sample. You have to, of course, get it off the surface and return it to Earth. That's a very long pull for us at this point in time.
Steve, just another question. When it comes to your space lunar communications that is in the old Boeing building, are you using any government furnished equipment or facilities? Like there's got to be some excess capacity at the Mission Control Center. Have you done anything like that or plan to?
So we looked at using the Deep Space Network, and it's very expensive. And so we traded that with going out and contracting with KSAT and with Parks Antenna and Morehead State. And we determined that that was a much better deal for us. And also we would control availability. We would maybe not necessarily have priority with the Deep Space Network over our 2-week mission timeline. So we aren't using any government assets there. We also decided to build our own control center. The payloads that come in, especially our commercial payloads, we have to have the ability to bring their scientists in, and while we will be helping them send commands to their payloads, they will be operating their payloads when we're on the surface. So it was felt best that we have our own control center, and it's pretty eye-popping. Troy LeBlanc and John Graves, who both have NASA pedigree, of course, designed that, and they it's going to be fun to fly the mission out of them. It also allows our engineering team to fly the mission. All right, so we don't have dedicated operators. We're not big enough yet to have a dedicated operation team. We have dedicated leads for each of that, and it'll be a 24/7 around the clock for about 3 weeks from launch till sunset.
Okay, thank you again.
Yep. Let's see.
Well, any other questions for Steve?
Let me share you one other thing. So we put out a newsletter every week, or I'm sorry, every month. See if I can share this. I just wanted to show you our latest one. It shows a lot of the employees. This is Mary Faith. These are some of the composite struts. She's getting ready to apply the adhesive to that to insert the fittings. We obviously had to suffer through the freeze, and this was Steve's message to everyone about helping out. We had several of our team that had much more significant impacts than just losing power. This is pretty remarkable. NASA built these tiles of the lunar landscape from some LROC imagery, and built these 3D renderings of various places. They don't go together tile to tile necessarily, but they were doing this for the something called SPLICE that's being developed for their precision landing and hazard avoidance needs on HLS, we borrowed the tiles so that we could fly our precision landing and hazard avoidance system suspended from a crane and then just use it to traverse. And it's, again, part of that early hardware software integration, and to have some realistic, other than synthetic imagery being processed through our computers to demonstrate the ability of our navigation system to guide us to a safe landing zone. This is some of the engineers, Brian and Tim Crane, during that testing. This is what I mean by the synthetic imagery. Here's an original imagery image, and with some synthetic imagery techniques, you can come up with the lighting that image should be having when we're doing our landing, depending on the date. Here's the team in our mission control room doing a sim training for our power descent initiation. This is a test of our rocket engine that we just finished last week. Ran the engine for for 2 full minutes, did a complete deep throttle all the way down and throttled back up, and demonstrated clean engine shutdown, which are all steps toward qualifying our engine so we can land. We've also created the ability to test our igniter in a vacuum by having a tiny trash can barrel size vacuum chamber on the back of that truck that allows us to demonstrate that we can ignite our engine. We've got our propellant tanks in work, applying the insulation, and we're building an additional test stand. This is some of the electronic assembly that's going to actually go on our second test stand. That'll be vertical so that we can get all the right harmonics out of our propulsion system. This is Mike Watts. He's our build manager, and this is the vertical test stand on the back of a second truck that we're well on our way to fielding by the end of May for our final qualification runs. So it's a lot of fun to do this, and it's a lot of fun to do everything that is involved in getting a spacecraft to the moon.
Yeah, I think a lot of us are jealous. Sounds like a great thing.
How old's your team, Steve?
Pardon?
How old is a team on average?
On average, I would guess it's probably in their 40s. We have I would say 10 to 20 people my age, or in their late 50s, early 50s, who are more senior and serve as managers. We've got some folks like Rob Moorhead, who are more middle of their career, and John Graves, I mentioned earlier. And then we have quite a few fresh ups. So I would say around 40, if I had to guess, maybe a little bit younger. It's a very good mix. The other thing we have is some very experienced technicians. So that's where we really haven't. We have one intern technician, but most of our technicians have decades of experience, and we're going to need it to put this thing together right.
Okay, outstanding, Steve. I certainly learned a whole lot. I think all of us wish Intuitive Machines and you and your team good luck in reaching the moon. That's kind of what it's all about.
No doubt. So thank you. I appreciate it. Enjoyed the opportunity.
Yeah, great. So let me, so for everyone else, let me tell you about our next first Thursday meeting. Will be a pretty interesting one. You know, we're coming up on the 40th anniversary of STS-1. So for our April first Thursday meeting, which will be on April 1st, we're going to have a roundtable discussion with question and answers by several of the people who participated in STS-1. So we've got Bob Crippen, Dick Truly, Neil Hutchison, Chuck Lewis, and Gene Kranz will be our participants in a narrated discussion. So that'll be a good one. Again, April 1st at 2:30 Central Time. So thank you, everyone. Appreciate you tuning in. We'll see you next month. Thank you, Steve.
Thanks.
Hey, Steve, before you go, could you send the newsletter to Stokes and send it out to us?
I'll check, but I believe so. I know it gets distributed within NASA already, so I don't think that would be any problem with that. But
That'd be nice. So, thanks.